Daniel Walsh, who is going to slam on the topic of Mojave microbes as Martian analogs. Daniel is a master's student in microbiology in the School of Life Sciences.
Recent evidence for robotic probes shows us that Mars was likely a much wetter place eons ago. Even more interesting than that is that there is liquid water in the Martian subsurface today in the form of salty brines that we can see seeping out of the edges of craters as those dark lines. Even though Mars is colder than the Antarctic, the water is able to remain in liquid form thanks to a variety of salts and a substance called perchlorate. Now, perchlorate is rocket fuel, but there are microbes able to use it the same way we use oxygen. This leads us to an intriguing question. Is there now, or has there been, life on the red planet? Turns out our own Mojave Desert may be key to provide insights to such a question, because right in our own backyard are Mars-like environments. For example, in Henderson, the Petcon factory that made perchlorate exploded in 1988. Just a few miles away, I was a kindergarten student in recess at the time, and the tremors knocked me flat on my bottom. But other than that, the disaster released several tons of perchlorate into the groundwater. And here and in surrounding areas, there are these kinds of microbes living as happy as can be in a Mars-like environment. Additionally, we have other locations that have very similar salt chemistry that we see on the Martian surface. So in a way, the Mojave Desert is like a displaced Martian oasis. Now, these types of microbes have already been grown in synthetic Mars-like brines, but they were not fed nutrients found on Mars. We naturally want to take the next step and use a nutrient that is. One possibility is methane. There are seasonal methane plumes on Mars, and we don't know the source. It could be biological, maybe geological, but either way, the methane could be feeding microbial communities in its subsurface. Now, we can make similar communities that use perchlorate and methane, and we are going to expose those communities to these Mars-like brines and test the limits for life in these kinds of conditions. Then, we're going to recommend some of these for deployment to the International Space Station, where they will be exposed to the harsh, open vacuum of space for several months. Now, other hardy microbes have survived such exposure, but if we can do so with a potentially Mars-like microbe, it will allow us to better evaluate the viability of the panspermia hypothesis, which suggests that maybe life was transferred between the planets via meteorite impacts several millions of years ago. In 1988, my official education began with an explosion of rocket propellant. Who knew that would be still propelling me forward in my higher education today? Thank you.